Then what about if you want to determine a probability for x instead of a set? That is, x is normally distributed but not standard distributed. So let c be some constant. This inequality we can rewrite. If we subtract the expectation value of x on both sides, then we have this equivalent inequality. So this is the expectation value of x. If we also divide both sides with the standard deviation, we get this inequality. Here on the left hand side is a random variable we get by taking x minus the expectation value and dividing by the standard deviation. One can show that this random variable is standard normal distributed. So let's call this set. Then we get this inequality. So this inequality is equivalent to this one. So we can replace this one with this. That means that the probability for x being larger than c is the same as the probability of z being larger than this. And this here now we can use the table to calculate. So assume that x is normally distributed with expectation value 19 and standard deviation 3. If you want to determine the probability that x is larger than 25, then we can use the formula we just saw to replace this one with the standard normal distributed set. If we at the same time change this to 25 minus this one divided by this one, this is equal to 2. And this one we can just check in the table. So when set alpha is equal to 2, we get this probability. So the probability is equal to 2.28%. As another example, assume that x is the height of a random person in centimeters. Assume that this is normally distributed, an expectation value of 175 centimeters and the standard deviation of 15 centimeters. We want to determine the probability for a person having a length between 170 and 180 centimeters. Then first we can use the expression we have seen before. We can take x less than 180. So if here is 170, here is 180. Then we take this one, which is this one, and then we subtract this part here. That is x less than 170. Now we just can change this to set, and then we need to take minus 175 divided by 15. And the same here. And this is equal to a third, and this is equal to minus a third. And rounding this off to 2 decimals, and switching this one to that, and at the same time taking 1 minus. And here we have by symmetry, we see that we have this twice, and this one we can read off in the table. So 0.33, then we are here. So this probability. And this just simplifies to 25.86%. So that's the probability that the random person has a length between 170 and 180 centimeters. Here we have a normally distributed random variable x. If we change this one to set, then we have set alpha somewhere here. The corresponding point here on the x is this, and that corresponds to set alpha standard deviations. That means that the probability for this part is alpha, and also for this corresponding part it's alpha. And by symmetry reasons it's alpha here also. Then the whole thing is 1, and we take away these 2, we get 1 minus 2 alpha, and that's the blue part in the middle. So the probability of having an x between this value and that is 1 minus 2 alpha. And this interval is this starting point to this endpoint here. So the probability of getting an x in this interval is 1 minus 2 alpha. So if we take an example, if x is normally distributed with the expectation value of 100 and standard deviation of 10, let's say we want to determine an interval around the middle point 100, that x will end up with 90% probability. So that means that 1 minus 2 alpha should be equal to 90% or 0.9. If you just solve this equation, we get alpha equal to 5%. Then we can read off in the table set 5%. So we find 5% here. Then we see that it's 1.645. And then we can just put in it here into this interval. And then we get this one, which is just equal to this one. So the probability is 90% of having x in this interval.